Morning, guys, welcome back to day 2 of week 9. Today we're going to continue with the topic that we started yesterday. Yesterday we didn't place the topic name. Today we will. We saw yesterday some definitions and we did one linear inequality and we graphed it in the coordinate plane and saw why the points on this area, shaded area, are part of the solution and why the ones that are outside the shaded area are not part of the solution. So today we're going to work with a system. Today is March 1st, 2022. Continue right after you finished copying the other part and place the date at the top. So it says March 1st, 2022. And these are the exercises that we're going to be solving. As you can see, I'm giving you 2 inequalities, not just one, meaning that this is a system. You are supposed to solve the system and graph it, okay? So the first thing that we're gonna do is call this one inequality 1 and call this one inequality 2, okay? And we're gonna find the intercepts for inequality 1 and the intercepts for inequality 2. So for inequality 1, y is greater than x. First thing, is it open or is it closed?
Open.
Open. In other words, we're gonna graph it with a, what type of line? Is it a solid line or a dashed line?
Dashed line.
The dashed line. That's how we're gonna graph it, okay, a dashed line. So we're gonna find the intercept in x. And the intercept in x is when we leave an empty space for x and y is 0. So we're going to say 0 is greater than x. Now we need to follow the 3 specific rules where the variable needs to go on the left, the constant needs to go on the right, and if there's a negative sign, you need to flip. Now, pay attention to this. The constant is 0. When we have the variable already by itself and the constant is a 0, we can just rewrite it going the other way around. How does that work? So we place the x over here and we place the 0 over here. We flipped it from sides, okay? Now the only thing that we need to do is to flip also the equality sign. So it is no longer greater than, it will now be less than. And how do I know that this is correct? To which side is it pointing, the little border of the inequality? Is it pointing to the x or is it pointing to the 0? It's pointing to the x. Same thing here. It's pointing to the x. So we just flipped everything around because we had just a variable, one variable all by itself and a constant all by itself. So it means that over here, we're going to place a 0 because the intercept in x is 0, 0. Now we're going to find the intercept in y, where x is 0, and we're going to find the value of y, sorry. So we're going to say y is greater than 0 because we replace this x by 0. So again, I got 0, 0. Now look at this. I got 0, 0 as an intercept in x and 0, 0 as an intercept in y. So basically, it is the same point, right? 0, 0 is exactly the same thing as 0, 0. Yes or no? Yes. So that means that I only have 1 point. So I'm going to do this not that pretty, just like that. So that means that this point is the origin, 0, 0. And this other point is also the origin, 0, 0. How many points do we need at least to graph a line, a straight line?
2.
Exactly, I need at least 2 points. So that means that I cannot work with that because I only have 1. So what am I going to do? Okay, so I'm going to do another procedure since they're exactly the same. I'm going to say that x is going to be 1. Instead of 0, it will be 1. And I'm going to find out the value of y. So I'm going to say y is greater than, instead of x, the value 1 that I placed over there. So y is greater than 1. So that 1 is the one I'm placing in here. And this is the number that I'm going to use, this order pair. Okay, so I'm using this one, and it doesn't matter which one because they're exactly the same. Okay, so I'm going to use one of those. I'm going to erase this because we don't need this yet. We're going to go now with the second inequality. So for the second inequality, I have the y is less than or equal to negative x plus 2. Is this open or this closed?
Close.
Close.
Closed. So I'm going to graph it with a dashed or a solid line.
Solid line.
Solid.
Solid line. So I just place it like that so I don't forget, okay? Now I'm going to find the intercept in x. Just the same thing, where I leave an empty space for the value of x and y is going to be 0. So I'm placing 0 is greater than or, less than or equal to negative x plus 2. Now we go and work with the 3 specific rules where I need to have variables on the left. Do I have variables on the left? All right. So I'm going to pass this negative x with an inverse operation to the right. If it's negative, it goes
Positive.
positive. Very good. So this is going to go positive. And I'm going to have x, because 0 plus x is less than or equal to positive 2. And that positive 2 is the one that I'm placing over here. Now I'm finding the intercept in y, where x is 0. And we're finding y. So x is going to be 0. So I'm going to have y is less than or equal to negative 0, because there's a negative. Okay, so negative 0 plus 1. But I don't care if it's negative or positive because 0 is 0, so it gets canceled. So y is less than or equal to positive 1. And that 1 is the one that I'm placing over here. And we finished. We finished with the first part. Now we need to graph it. Okay. So I'm going to draw my coordinate plane. As you can see, I don't need it to be so big because I got 0, 0, 1, 1, 2, 0, and 0, 1 as order pairs. So I don't need it to be so big. So I can work with doubles, okay? Just to make it a little bigger. So this is 2, this is 1. This is going to be 0. This is negative 1. This is negative 2. Positive 1. Positive 2. With the x. This is the y. Negative 1. Negative 2. And that's it. I'm going to graph this one in blue. And I'm graphing this one in green. Okay, so the blue one. 0, 0, right in the origin, and 1, 1. 1 on the x, 1 on the y. Remember, I'm using a double scale. 2 squares are 1 unit. And now I'm going to connect it with a straight dashed line. Since I'm working without a ruler, I'm not able to do a straight dashed line, just like that. So I'm going to do it this way, and then I'm going to dash it, okay? Since you're using ruler, you can dash it already. Okay, that's the first dashed line. Now, before I continue, we're going to notice the y. So, should I shade up or should I shade down? Always notice the y-intercept. So should I shade up or should I shade down?
Up.
I'm going to paint from the dashed line up. Remember, you're supposed to paint it all the way. So no lines, just a painting all that side, solid painting. For me, it's difficult with this little thing. It goes dashed all the way. And you can see I'm passing a little bit over the coordinate plane, and that's okay. Let's go with the green one. Green one is 2, 0. So that means it is over here. 2 on the x, 0 on the y. And 0, 1. 0 on the x, 1 on the y. So I connect those 2 points, and you can see I connected first and I shaded first. Now I'm doing the second one. I'm graphing the points, and now I will be connecting and then shading. Since this is solid, it doesn't matter. So I don't have to shade anything. I mean, I don't have to dash anything. And we notice always the y-intercept. So does it go down or should it go up?
Up.
Down from the y-intercept. So I'm going to shade down. And I'm shading everything all the way until my coordinate plane finishes. Not just a little part, it's all the way down to where the coordinate plane finishes. You can even go a little bit farther. A little bit further. Now, you can see that I got an area over here that has to be also in blue. I'm going to continue to extend this part. It doesn't matter, okay? And wherever the 2 colors meet, all of this that I'm placing in brown, wherever the 2 colors meet, that is the solution of your inequality system. So this is like in brownish. That is the solution of your inequality system. Wherever the 2 colors meet, that will be the solution of your system. So you're going to paint over that with the 3rd color. So you need at least 3 colors, okay? One for one inequality, the other for the second inequality, and the 3rd one to shade over the area where the 2 colors connect. And what's your solution? That's your solution. That's where your exercise finishes. Questions? Questions?
No.
No questions. Everything is clear. Everything is completely clear.
Yes.
So that is how we graph a system of linear inequalities. Okay, so we do the intercept for the first one. We do this intercept for the second one. We graph the first order pairs of the first inequality. We connect them according to the type of line we need to use. Okay, I know that this was supposed to be open. Okay, so don't worry, it could be open or you can do it like that. It doesn't matter. It's just one point. It doesn't matter. Okay, it's supposed to be open as well. So in this case, it's supposed to be a circle. It's supposed to be an open circle. Because the intercepts or the open ones should also be open circles. Okay? Questions? No? Everything is clear? Okay. So let's do another one. The exercise that we will be doing is y is greater than x minus 1 and y is greater than or equal and less than 3x plus plus 9. Let's do it plus 9. Okay. That is my new system. Okay. Step 1, call one of the inequalities inequality 1 and call the second one inequality 2. It doesn't matter if, for example, Iker wants this one to be number 2 and this one wants to be number 1, or if Valeria Chong wants this to be number 1 and this number 2. It doesn't matter the order, okay? It doesn't matter. It's just for more detail and being more ordered in your notebook, okay? So inequality 1. Y is greater than or equal to x minus 1. I'm going to find the intercept in x, where I live in an empty space for x, and y is 0. Instead of y, 0 greater than or equal to x minus 1. Now I go with the 3 specific rules. Variables on the left, so this x goes negative. So I got negative x is greater than or equal to negative 1. Now remember, when we only have a negative sign, I just go around and flip everything and change every sign on both sides. So this is going to be x. Now it's not going to be greater than, now it's going to be less than or equal to positive 1. Okay? Basically, we did exactly the same procedure without actually passing the negative sign to the other side, dividing or placing an invisible one. We just flipped everything, signs and inequality. Okay, so it is 1, 0, the intercept in x. So we go with the intercept in y, where x is 0, and we're going to say y is greater than or equal to 0 minus 1. So y is greater than or equal 0 minus 1, negative 1. Okay. And that's the number that I'm going to place over here. Negative 1. Let's make it prettier. There, negative 1. And I'm going to put the intercepts for my first inequality. Now I'm going to my second inequality. Y is less than 3x plus 9. So the intercept in x, just like in the first exercise, is where I leave an empty space for the x, and I give the value of 0 to y. 0 is less than 3x plus 9. Now, variables should go on the left, so this 3x goes to the other side with an inverse operation, which is negative. So negative 3x is less than positive 9. Now, constants on the right, it is good. Now we leave the variable completely alone, so this 3 goes to the other side, dividing, but it is negative. So what else do we do? Exactly, we reverse or we flip the inequality sign. So I'm calling it flip. Then I'm going to say x. Now it's no longer less than, now it's greater than 9 divided by negative 3. How much is 9 divided by negative 3? Which is 9 divided by negative 3? How much is 9 divided by negative 3?
3.
9 divided by negative 3?
Negative 3.
Negative 3.
Exactly, negative 3. Okay, so we place that negative 3 over here. Now we find the intercept in y, where x is 0, and we're going to find the value of y. So we're going to say y is less than 3 instead of x, 0 plus 9. I cancel this out because 0 multiplied by anything, it's still 0. So y is less than 9. And now we're ready. Okay, now I forgot. Is this open or is this closed?
Closed.
Closed, so it is a what
Solid
type of
line.
line? A solid line, very good.
And the notary is open and a dash line.
Exactly, very good. Sometimes both are open, sometimes both are closed. Sometimes we got a mix of one closed and one open, okay? Now we're gonna graph. So we do need 9. So we do need a big number for the y. So I'm gonna go in units of 1, okay? 9, 8, 7, 6, 5, 4, 3, 2, 1. 0. This is going to be in blue, and this is going to be in green. Okay, so for the blue one, it is closed, so it's 1, 0 on the x, and 0, -1 on the y. It is closed, so I just connected with a straight line, a solid straight line. And I'm going to do it bigger, okay? I'm going to extend my line long enough in both sides of my inequality, on my coordinate plane, sorry. And remember to draw the arrowheads. Now, should I shade up or should I shade down? Always notice the y, up or down? Up or down? Look at the inequality for the y. Up or down?
Down.
Are you sure down?
Up.
Look at the inequality. The inequality says greater than. Greater means up, always, okay? Because it goes towards the positive. So greater means up, so I'm gonna shade up of my inequality, of my coordinate plane. Okay, so I'm shading up. You're supposed to paint it, remember. I cannot paint it, so I draw lines. You're supposed to paint it. So that's my first inequality. Let's go with the second one. The second one is open, okay? So I'm gonna draw an open circle. So we got 0, -3, -1, -2, -3. And y it's 0, 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9 over here. I draw an open circle. I connect those two open circles with a straight line as well. And remember that this one is open, okay? Does it mean that I need to dash it? Okay, so I'm dashing it. Okay, it's done. And I'm supposed to paint it up or down?
Down.
Down, very good. Down from the y intercept, right? So down from the y intercept. That exact area where the two colors connect, that is the solution of your system of inequalities. Meaning this part over here, like cone way. This part over here is the solution of your inequality. Questions? Questions? What does this mean that it's a solution of your system? Well, the blue part will be true for the first one. The green part will be true for the second one. Where the brownish one will be true for both of them. Okay, so if I place, for example, the point 0, 0, that's right in the area of connection of the colors of the brownish area, and I substitute that 0 in both of them, it will be true. Okay, so let's try it just for you to understand. So 0, 0, that's the one that I chose. I'm going to substitute it in both. I get 0 is greater than or equal to 0 minus 1. 0 is greater than or equal 0 minus 1, negative 1. Is 0 greater than negative 1? Yes. And let's go with the other one. 0 is less than 3 times 0 plus 9. 3 times 0 is 0, so 0 is less than positive 9. Is 0 less than positive 9? Yes. So any point, whatever point that's inside the area of both colors will make the system of inequalities true. If it's only where the brown of the blue part is, which in this case could be, for example, this point over here, that's -1, -2, -3, -4, 1. This point will be true for the first one, but it will not be true for the second one. If I pick this other point, this is 2, -2. This one will be true for the second one, but not for the first one, because it's not part of the solution. But if I pick this other number over here, this is 1, 1, 2, 1, 2. This, just like this one, will be true for both, okay? That's what it means. So it will be part of the solution because it is in the area where the two shadings connect. Questions? No questions? Okay, then. This is the second part of our topic. Let's place the topic name. What is the topic's name? What is the topic?
Systems of inequality.
So we didn't solve only systems. We solved one. We're going to call it graphing linear inequalities. And this will be taking into account also the systems, okay? So graphing linear inequalities, and it also talks about the system, not just one random inequality, okay? It is just one normal or systems, okay? That will be the topic's name. So do we have any question whatsoever about the topic? We clear? Okay then. So this is our very last topic for this part of